Yo, what's up? It's Mr. Mangle and hanging out with Miss Gibbs.
Hi!
Yeah, so we're about to do some pre-calculus. So the worksheet that you're going to need for this lesson is the application problems for the law of sine and law of cosines worksheet. Looks like this. You should have this in your packet. So this is the attack plan for the application problems that you are going to be doing involving the law of cosine and the law of sines. First we're going to walk through this chart, and then I'm going to show you the first few application problems, so you'll have an idea of how to do them. And if you need extra help, just give me a call, send me an email, or drop me a text. Call is probably the best. If you do call, leave me a voicemail if I can't get to you. Awesome. So, first question that you have to ask yourself is your calculator in the right mode? So, is your calculator in the right mode? Well, what are we going to do? You have to check it. It's in the box. Check it. And change it. You might be asking, oh, well, I don't remember what mode it's supposed to be in. Well, we know that since we're working with degrees with the law of cosine and the law of sines, it has to be in degrees. Second thing, have you been given a diagram? If so, even if you do have a diagram, you still need to draw your own. So, draw one. And I highly suggest drawing all the triangles that you possibly see, which you'll see in the sample problems we're about to get to. Third step, are there any right triangles in the diagram? If so, we can use the Pythagorean theorem. So if so, we use Pythagorean theorem. Fourth step, do you have the measure of an angle and its opposite sides? Do you have a measure of an angle and its opposite side? If you do, and this, as we remember from the lesson that we did on January the 5th, which is today, but this is the lesson that's for the 6th. So, as you know, that if we have an angle and its opposite side, you use the law of sines. But then you're asking, okay, well, what if we have three sides or two sides and the included angle? You know that you're going to use the law of cosines. Number 6 asks, have you found the needed information? Well, even if you haven't, keep going until you do. So keep going until you find what you're looking for, until you answer the question that they're asking. Number 7, do your answers make sense? Is the biggest angle across from the biggest side? Is the smallest angle across from the smallest side? And do all the angles add up to 180 degrees, etc.? Do they? If not, so in the box, if not, try it again. If not, try it again. So we learned, based on the law of sines and the law of cosines, how to find the measures of angles or the measures of sides given a non-right triangle. So whenever we have a triangle that does not have a right angle, we can use the law of sines and the law of cosines in order to make sure that we know how to figure out the missing pieces of information. What we're going to be doing today is we're going to be exploring application problems that will allow us to answer certain questions. For example, finding the length of a lake, or being able to measure the angle from Earth between Jupiter and the Sun. Really cool stuff that we can do with this. So let's get to the model problem. Model problem. So the model problem reads, two ships left a port at the same time. One ship traveled at a heading of 318 degrees. The other ship traveled at a speed of 22 miles per hour at a heading of 198 degrees. find the distance between the two ships after 10 hours of travel. So what are we looking for? We're looking for the distance between the two ships after 10 hours of travel. Two ships left a port at the same time. So we know, let's just call this our port. We had two ships that left that port at the same time. One ship traveled at a speed of 18 miles per hour. So one ship traveled at a speed of 18 miles per hour, heading 318 degrees. All right, well, let's just say this is our reference point. Let's just say this is the shore. Well, 318 degrees on its compass would take the ship this way. So the ship travels 318 degrees from the shore. How far does it travel, you might ask? Okay, well, we know that it's traveling at a speed of 18 miles per hour. And how long is it going? 10 hours of travel. It spends 10 hours traveling. So 18 miles per hour. So this is for ship 1. Let's just call it ship 1. So for ship 1, 18 miles per hour times 10 hours, it traveled 180 miles. So we know that the distance it traveled here is 180 miles. So what else do we know? The other ship, or ship number 2, hey, you guys want to come say hi? I'm recording a video. You can say what's up if you want. No? Oh, well, what grade are you guys in? 8th? 7th? 7th graders say what's up. 6th? Cool. 6th graders, 6th and 7th graders say what's up. Study hard, study math, it's awesome. You get to solve cool problems like this. So, ship number 2. Ship number 2, we know, travels at a speed of 22 miles per hour. 22 miles per hour. So 22 miles per hour, we know that they both travel for the same amount of time. So times 10 hours, that leaves us with 220 miles that ship number 2 traveled. So it says that the other ship traveled at a speed 22 miles per hour at a heading of 198 degrees. We know that that's going to be around here. That would give us an angle of 18 degrees from the horizontal and traveled 220 miles. So ship number 2 traveled 220 miles, 18 degrees below the horizontal, and ship number 1 traveled 180 miles. It said at a heading of 318 degrees, so that's all the way around here. Well, how far would this be? It would be 360 degrees minus 318 degrees, which would give us 42 degrees. 42 degrees below the horizontal. So, we figured out everything that they've asked us for. Well, we figured out like what our diagram must look like. But we have to find what question are we trying to answer. Well, we're trying to find the distance between the two ships after 10 hours of travel. So this is where ship number 2 ends up. This is where ship number 1 ends up. Wow, what do you know? We have a triangle. We're trying to find this distance between the two ships. So let's call that distance h. So we know this is 18 degrees below the horizontal. This is 42 degrees below the horizontal. Let's create a new diagram. Let's create a new triangle. So, well, we don't have to create a new triangle. We already have our triangle. So this is our diagram. If we have 18 degrees and we have 42 degrees on the other side, is there a way for us to find this final angle? Yes, there is, because you know that the sum from here all the way to this side, these angles have to add up to 180 degrees. So 42 degrees plus 18 degrees gives you 60 degrees. The remaining angle has to be 120 degrees. So the remaining angle has to be 120 degrees. You're looking for h. You're looking for the distance between the two ships. is there anything that you can use in order to find that distance between the two ships? Well, we have, what do we have? You have to see, what do we have? We have two sides and the included angle, or the slice of cheese between the two slices of bread, because it is the angle directly between those two sides. Okay? So if we have two sides and an included angle, what can we use? Well, if we get our chart back out, you know that you can use the law of cosines. So let's use law of cosines. So using the law of cosines, what we're going to do is we're going to figure out, Miss Rawlings wants to say what's up. Alright, cool. We're going to be able to solve for the distance between the two ships. So let's call this the value that we're looking for. So you know that that's going to be h squared is equal to our two sides, a squared and b squared. So 220 squared plus 180 squared minus 2 times 220 times 180 times the cosine of h, angle h. Do we know angle h? Yes, we do. It's directly across from our side h, 120 degrees. That is how you should write it, exactly like this. So now we have to ask ourselves, all right, well, how are we going to find the distance between ship 1 and ship 2? All we have to do now is solve for h. Can we do that? Yes, we have every single variable filled out except for h. How are we going to? So we just take the square root. Leaves us with h is equal to the square root of 220 squared plus 180 squared minus 2 times 220 times 180 times the cosine of 120 degrees. Can I solve this? Heck yeah, I can. What do? I don't, okay, so this is what I want you to make sure that you don't do. Do not cancel the square and the square root just because that looks fancy. No, you cannot cancel the square and the square root because this is not a single term underneath the square root. My advice is go ahead and evaluate everything that's under the square root first. So if you evaluate this 220 squared, go ahead and write that down, whatever that is, plus 180 squared, write that down, subtracted this entire term. So go ahead and evaluate 2 times 220 times 180 times the cosine of 120. Whatever you get there, subtract it from whatever you got for the first two terms. Then take the square root. The answer that you will end up getting is that h is approximately 346.987 miles. That is the distance that the two ships are approximately away from each other. Remember, we're rounding to 3 decimal places. Cool. So, now, pay attention to the next video. Gotta go to a meeting. Deuces.